Today we will see how to solve a linear programming model by using Simplex method. For this method, let us consider an example of a company which manufactures bowls and mugs. Let number of bowls manufactured are represented by the variable x1 and number of mugs manufactured are represented by variable x2. These two things are manufactured by using labor, hours and clay, which is the material to manufacture the bowls and mugs. So this LPP can be formulated as maximize Z equal 40x1 plus 50x2, which represent nothing but the profit, since we have to maximize it. Okay, it is subject to the constraint. The first constraint, that is x1 plus 2x2 less than equal to 40. This represents the labor constraint. And the second constraint, 4x1 plus 3x2 less than equal to 120. This represents the clay constraint. Okay, with the condition that variables x1 and x2 is greater than equal to 0. The first step involved in any linear programming problem is to convert it into a standard form. As we already know, standard form is a form in which all the constraints are represented as an equation and the objective function is of maximization type. So first we consider the constraint for labor. This is x1 plus 2x2 less than equal to 40. To convert it into equality, we'll write it as x1 plus 2x2 plus we add a slack variable s1 which is equal to 40. So where s1 is the slack variable which represent the unused labor hours. Similarly, we consider the second inequality. To make it into an equation, we add another slack variable, say s2, which is equal to 120. Then s2 is also a slack variable which represent the unused amount of clay. S1, what S1 was representing? S1 is representing unused labor hours. Okay, now these slack variables S1 and S2 are added in such a way that this S1 and S2 should be greater than equal to 0. And we were already having the variable x1, x2 greater than 0. So we will have in total x1, x2, s1, s2 greater than equal to 0. Now in standard form we require objective function to be of maximization type. In our problem it is already maximization. So we will write maximize z is equal to 40x1 plus 50x2. Now here we will write the slack variables also. Now the slack variable represent the unused resources, so they will give us 0 profit. So this will be added as 0s1 plus 0s2 in the objective function. Now the second step is to identify the basic feasible solution. Basic feasible solution. Since this is the solution which we are obtaining initially, so we can call it as initial basic feasible solution. In short form, we can write it as IBFS. Okay. Simplex method selects the origin as the initial basic feasible solution because the value of decision variables, which are x1 and x2, are always known at origin. So for initial basic feasible solution at origin, what we will having that x1 is equal to 0 and x2 equal to 0. x1, x2 are called the decision variables because these are the variables initially present in the problem. So that's why we put x1 and x2 equal to 0 in the standard form. So when we put this x1 and x2 0 in this first equation, what we will get? 0 plus 2 times 0, that is 0 plus s1, that is s1 is equal to 40. Similarly, from the second equation we get this 4x1. x1 is 0, so this will become 0. x2 0, so this also becomes 0. So we'll get s2 equal to 120. This represents the initial basic feasible solution. In other words, at origin, when there is no production, all the resources are unused. Okay. Now the next step is to make the table, to make the simplex table. Now we are making the first table. In first table, first we need to identify all the variables involved in the problem so that we can get from the objective function. Objective function, we can see the variable x1, x2, s1, s2. So we'll write all the variables in form of row. x1, x2, s1, s2. Now, next is fill the Cj values. Above this row, we have to write all Cj values. Cj values represent the coefficient of the variables x1, x2, s1, s2 in objective function. In objective function, the coefficient of x1 is 40. So it will come above x1 here. The coefficient of x2 is 50. It will come here of this. Similarly, the coefficient of s1 and s2 is 0 and 0. So this is the first row. Now the second thing is list the basic variables as column. What are the basic variables? Here the variables which are having non-zero values. These two variables s1, s2 in the initial basic feasible solution are known as basic variables. So we have to list the basic variables here as s1 and s2. Okay. Now after this, what we have to write? This Cj value, the value of s1 and s2 in Z, which is same as written over here. So it will become 0 and 0. Also, what is the value of s1 and s2? The basic variables in initial basic feasible solution, it is 40 and 120. So we will write this value 40 and 120 under the column quantity. Okay, which we can also denote it by RHS, that is right hand side of the equation. So for S1 it is 40, for S2 it is 120, that we will write here. Now we have to fill these entries in the table. Now we can see from the standard form, S1 represent the variable in the first constraint. So in the first row we have to write, so below this we will write the coefficient of x1, x2, s1 and s2 in the first constraint. So if we see here, what is the number with x? It is 1. So we will write here 1. We check the coefficient of x2 in first constraint. It is 2. So it will come here as 2. And we check the constant of S1 is 1 and there is no S2 which is 0. So that's why it is 1 and 0. Similarly, S2, it represents the constant in second equation, the slack variable in second equation. So similarly, we write the coefficients of x1, x2, s1, s2. Now since there is no s1, so we can write it as 0 s1. So the coefficient of s1 is 0. As we did here, the coefficient of s2, 0. So now the second row will be 4, which is the coefficient of x1 in second constant, 3, 0 and 1. So this is initially we'll get the table. Now we need to calculate the value of Zj. To get the value of Zj, we need to multiply the Cj column. This is Cj column. This is Cj row. So we need to multiply this, we call Cj, this column. If we go like this. Okay, and this is Cj row. Okay, now what to calculate Zj, what we have to do is we have to multiply Cj column value by each column value under the quantity x1, x2, s1, s2 and then add. Let's see, like suppose I want the value here under the quantity x1. So what we'll do, 0 multiply 1. Let's do the calculation, which is 0. Then 0 multiply 4, which is equal to 0. And then we need to add them. So when we add them, we'll get 0. So this value comes here. Similarly, if we want the value over here, so for that what we will do, 0 multiply 2, which is 0. Then 0 multiply 3, which is again 0, and then add them. Remember, we always have to add them. It is 0. Similarly, for this quantity, 0 multiply 1, that is 0. 0 multiply 0, 0 multiply 1, 0. 0 multiply 0, again 0. When we add, we'll get 0. Will come here, and similarly we'll get here. Now we want the quantity here as well. So for this, what we will get? How we'll get the value for this? 0 multiplied by 40. It's right here. We write it here. 0 multiply 40, which is 0. 0 multiply 120, which is also 0. And when we add them, we will get again 0. Okay. Now the next step is to find Cj minus Zj. So you can see directly Cj. So here we are going to use the row Cj, not column. Column we already used for Zj. And minus Zj. This value is Zj. Initially you will see that in all the simplex method, first value of Zj will be 0. So we want Cj minus Zj. So what we will do? 40 minus 0. That gives you 40. 50 minus 0 gives you 50. 0 minus 0 gives you 0. Again 0 minus 0 gives you 0. There is no term over here because there is no Cj value over there. Okay, so this is our first simplex table.